Okay, today we want to talk about the concept of slope. And slope is the measure of the steepness of a line, how steep one line segment is compared with another. Another word for slope is a word you'll recognize, rate of change. And in the last unit we talked about the rate of change as meaning the change in the dependent variable over the change in the independent variable. Well, that's another word for that is slope. Change in dependent over change in independent is change in the vertical, rise, over the change in the horizontal, which we call run. And we can calculate slope by taking the change vertically over the change horizontally, by taking the change in the vertical coordinates over the subtraction, in the horizontal coordinates. So let's take a look at calculating some slopes. I've got a number of line segments drawn down below. By the way, we use the letter M, small letter m, to represent slope. The letter S is taken up for other things like position in physics and stuff, so slope is represented by the letter M. So the first thing I want to do here is I want to calculate the slope of line segment OA. So if I take these 2 points and I'm going to measure my rise over my run, if I start at O, I'd have to rise 0 units, and I'd have to move horizontally 5 units. And so the slope is 0. For OB, I'm going to move from O towards B. So from O, my slope calculation is a rise. So I'm going to move up 2, and then I'm going to move right 5. So it's 2 up, 5 over, so the slope is 2/5, or 0.4. Let's do the slope of OC. So moving from O towards C, I'm going to move 5 units vertically, 5 units horizontally, and so we say the slope is 1 to 1. 1 unit up to 1 unit over. Alright, let's go with OD. So if I start from O, and I have to move up 8 units if I count that out, 3 units over, so the slope is 8/3. Which is 2.6 repeating if you want to do it in terms of a decimal. And OE, moving from here to here, my vertical change, my rise, would be 8 units. My run, I don't need to move horizontally, 0. And 8 divided by 0 is undefined. So you might notice a couple of things here. First of all, our slopes started from 0, and as the line segment became steeper, the slope moved higher. When the line segment was horizontal, the slope was 0. When the line segment was vertical, the slope was undefined. Alright, here's 3 more line segments to calculate the slope of. So we're going to go with OA. So again, our rise is 0 units. Our run is our horizontal movement, 5 units, so our slope is 0. Okay? If I go from O to B, alright, now I'm actually going to do this in 2 different ways. I'm going to move from O to B, and then I'm going to move from B to O, and just show you that my slope will turn out to be the same value. So if I start at O, I'd have to rise 3 units, which is negative, because I've gone downwards, and then move right 5 units, which is positive. So my slope is -3/5, which is -0.6. So I just showed you the slope calculation moving from O to B. What if I move from B to O? So if I start at B and I move upwards 3, my rise is 3, that's +3. I would then have to move left 5 to get to O. Left on a number line is negative. That still would have given me a slope of -0.6. So what I'm saying is it doesn't matter which point you start at in terms of finding slope. If you take into account your positives and negatives, positives moving up or right, negatives moving down or left, it comes out as the same value. Alright, let's calculate the slope of OC. So once again, I can start at either point, but I have to move in a continuous motion from one point to the other. So if I start at O, I'm going to have to come down 7, negative. Left and right will be right 2. I could have done it the other way from C to O. I could have started at C and moved up 7, so positive 7, or left 2, negative 2, slope still comes out to be a negative value. Finally, if I want to move from O to D, I'm going to have to move downwards 8 units. My run is 0, and so that's undefined, which is not surprising because we said earlier that a vertical line will have an undefined slope. So now a couple of things I hope you will notice from the top. First of all, when the line slants upwards, the slope is positive. That was in my first set of examples on my first grid. When the line slants downwards, the slope of the line is negative. If you have a horizontal line, the slope is 0. If you have a vertical line, the slope is undefined. And the last one says that the larger the absolute value of the slope, the steeper a line segment. Remember that absolute value refers to the positive of the value we're talking about. So if I roll back up here, we talked about these line segments here are getting steeper, and as they get steeper, our slopes are getting larger. Okay? On our second graph, as our slopes get steeper, remember they're negative slopes because the line segments are falling generally. As our line segments get steeper, our slopes as positive values, 0, negative 0.6, negative 3.5, if we think of those as positive values, those values are getting larger. Their absolute values are getting larger. So we say that the larger the absolute value of the slope, the steeper a line segment. Alright, here's a problem where we're asked to calculate the slope of the line segment. And I'm going to do this two ways. First of all, visually. So I know that slope is the rise divided by the run, the change vertically over the change horizontally. So I'm going to start at one of the points, and in a continuous motion I'm going to move vertically, then horizontally. So if I start here, I'm going to have to drop, which is negative, 8 units, that's my rise, and I'm going to have to run in a positive direction to the right 5 units. So the slope is negative 8 over 5. Had I gone in the other direction, starting from this point, I would have had to have moved up 8 units, which would have been positive 8, and left 5 units, which is negative 5. But I know that all of these fractions are the same. Now the second way I'm going to do this is I'm going to calculate the slope using the slope formula, which is the change in the y coordinates over the change in the x coordinates. And what's important to remember when you use this formula is that these values have to come from the same point, and these values have to come from the same point. So the 2 and the 1 represent point 1 and point 2. When I'm deciding which point is which, it doesn't really matter. What matters is that the x and the y are numbered the same in a particular point. So I could call this point the x value in point 1, the y value in point 1. This is the x value in point 2. This is the y value in point 2. Alright, and now let's apply our formula down here. I'm going to take the y value, 2, so y2. I'm going to take away y1, which is 7, divided by x2, take away x1, which is going to get me negative 8 over 5. Now I'm sure some of you are wondering, what if I had labeled my points the other way around? So I had labeled this point as x2, y2, and this point is x1, y1. Okay, so let me just show you that you get the same result. Okay, y2 minus y1, you would have had 7 take away the y value 1 over x2 take away x value 1. You would have had 8 over negative 5, and we know that these two are the same. So as you can see, it doesn't matter which point is labeled 1 and which point is labeled 2. What's important is that these match and these match. So I could call the formula y1 minus y2, as long as on the bottom I had x1 minus x2. These are all equivalent. Alright, we're being asked to draw a line passing through the given point with a given slope. So we have the coordinate 0, -3. We'll start there. And we have a slope, we have a rise over run of 2/3. Now remember that a slope is just a ratio. So when we say 2/3, any ratio that gives 2/3 is a legitimate amount to go by. So it could be 4/6, it could be 6/9, it could be -2/-3. So if I start at this point and I go up 2/3, I land here. If I go up 4/6, I land here. If I go down 2 and left 3, I land here. And you'll notice that all the points line up, and this relates back to the notion that we talked about in the last unit, which is that a line has a constant rate of change. So it doesn't really matter which 2 points you take on the line. If you take any 2 points on the line, then the rate of change is going to be the same. In this case, 2/3. Okay, here's another example. We have the point -4, 5, which is there. And our slope, our rise over run, is -3/5, which could mean a whole pile of things. It could mean the negative is on the top, or it's a multiple of that, or the negative is on the bottom. These are all a slope of -3/5. So if I start at my point and I have a negative rise, so drop 3, run 5, I land here. If I do that again, or from the beginning if I drop 6 and move right 10, I'm going to land there. So if I do any of these combinations from my starting point or from any of the points that I find one from the other, they're all going to line up, because a line has a constant rate of change. And so my slope is -3/5, which means the line falls, and my line looks like so. Any 2 points on the line will have a slope of -3/5.